Okay, in our next lesson, we're going to talk about coterminal and related angles, which does sound intimidating. It is not that intimidating. Our goal here is to focus on. Normally, we look at when we measure, say, an angle, we look at these small angles less than 90 degrees. So today, we're going to look at what happens when we look at angles that are bigger than 90 degrees. And to help us understand to do the sine, cos, tangent ratios of angles that are bigger than 90 degrees, we're going to use our XY axis. Let's go over some basic terminology. We're going to show angles on a grid. It's often helpful to do that, especially when we look at angles bigger than 90 degrees. Here is the terminology we will use on a regular basis. If you look at this diagram, I've got my XY axis. No, this is, we call this usually quadrant 1. And we usually use like Roman numerals to represent the quadrants. This is quadrant 1, and then over here we have quadrant 2. It's not showing that quadrant. And down here is quadrant 3, and down here is quadrant 4. Okay, so in our kind of normal setup, we gotta go counterclockwise. 1, 2, 3, 4. And that's helpful for our terminology when angles are bigger than 90 degrees. Okay, now the initial arm, we call the initial arm basically the x-axis. It's like we're going to measure the angle from the initial arm to the terminal arm. So the terminal arm is like this kind of line that that creates the angle. So notice we're not looking at a triangle here, we're just looking at an angle that's measured here. Okay, so theta is the angle from the terminal arm, or sorry, from the initial arm to the terminal arm, that angle measure there. Now you have to imagine that this terminal arm can swing around. So imagine it like grabbing this end right here and swinging it up to 90. So that would make an angle of 90 degrees between the initial arm and the terminal arm. But then imagine taking that blue line and swinging it past that y-axis, and that creates an angle between the initial arm and the terminal arm bigger than 90 degrees. Okay, so those are just some of the words we're going to use, and we always, and to be on the same page, we always kind of measure the initial arm to the terminal arm counterclockwise. So that's the angle that we always measure. It's counterclockwise. Feel free to stop this video and rewind and go over that part again, but we're going to use that terminology to measure angles. So let's look at what happens when we do go past that kind of y-axis and create an angle bigger than 90 degrees. So again, here we're going to use some other terminology here too. That theta, that's the bigger than 90 degrees, right in there. We call this the principal angle. It's the one we're looking at. It's the angle we're measuring. It's theta. It's that principal angle, and that's right here, principal angle. And we call that, it's in standard position, right? It's from the initial arm to the terminal arm. That's theta. But notice, when you do that, when that blue line comes across and it's creating this big angle here, this obtuse angle, there is another kind of angle created with the x-axis. Everything's always measured from the x-axis, by the way. Okay, so we never measure angles from the y-axis. We never look at this angle in here, never. Okay, so we always measure from the x-axis. So this other angle that's created with the x-axis we call, and it's labeled beta in this diagram, but it's called the related acute angle. It's always an acute angle. It's always less than 90 degrees. Because notice, if I come past 90, I've got an angle in here, it's less than 90 degrees. And it's always, as I said, measured from the x-axis. Okay, so I'm going to use these terminologies, principal angle and related acute angle, very often. Okay, we're going to talk about that a lot. So let's just go through some quick examples about sketching angles that are bigger than 90 degrees on this grid. So here's this example. Given the following principal angles, so these are the principal angles, we're going to determine the related acute angle. So let's just do A first. So notice the principal angle is 140 degrees. So remember, the principal angle is always measured from the initial arm, which is the positive x-axis, always the positive x-axis. And so we're going to measure 140 degrees counterclockwise, and we'll draw that terminal arm where that lies. Okay, so 140 degrees is bigger than 90, so we're measuring an angle that kind of goes past 90, and we need, so it's in here somewhere, because if we went all the way around, it'd be 180 degrees, and we're not that far. So there's my terminal arm. So it's the terminal arm. So this is my theta. It's my principal angle. It's 140 degrees. Can you guess what the related acute angle is going to be? This is the related acute angle. You guessed it. It's 80 degrees. It's 40 degrees. It's 40 degrees because it's basically the leftover from 180. So we took 140, sorry, we took 180, and we subtracted 140, and we got 40. That's the related acute angle. Let's do B. Okay, 200. Where's 200 going to lie? So, okay, so start measuring. We're going to get to 180. There's 180, and now we're into the 190s, and then we're going to stop at 200. There it is. Let's say that's 200. So the terminal arm lies in this quadrant, right? We swung it all the way around, and there it is. So this is theta, this big angle, right? It's way past. You see a bigger angle than 180 degrees. That's theta. And that measure is 200 degrees. Can you guess the related acute angle? Remember, the related acute angle is always the angle from the terminal arm to the x-axis. So this angle in here is that small angle that's measured from the x-axis to the terminal arm. It's always that way. Okay, so if this is 180, then this has to be the remainder. So this is 200, subtract 180, the leftover, which is 20. So the related acute angle here is 20 degrees. Okay, let's do C, which is 500. All right, where's 500 lie? Okay, we're going to go all the way around. There's 180. We're going to go back around. There's 360. Oh, if I got to keep going to get to 500. So if I keep going, I got to add 90 more to 360. Where does it lie? Where does it lie? Keep going. We couldn't do another 180. It's right there. Okay. So let's think about this. We went all the way around 360. So what's left over from 360? We take 500 and we subtract 360. We went all the way around, we're left with 140. So this angle from here to here is 140, and that's the same as at part A. So 500 degrees is almost the exact same angle as 140 degrees. We've just gone around 360 more degrees. So the related acute angle is the same because it's always this acute angle between here and here. It's always acute. It's always smaller than 90. So it's the difference between this, which is really like 140 sitting here, between here and here. So this has got to be 40 again. So the related acute angle for 500 is 40 degrees. Okay. The rest of your homework is I'm going to ask you to complete this investigation. Now you're going to have an option. You can download it right from the website here, print it off, and complete it. You can print it off. You could do it digitally if you've got some way to write on top of a PDF on an iPad or some kind of device like that, or you pick one up at school and you've got it there. So your job is to now kind of use this idea to go through this. If you watch the next video, I'm going to kind of just give you the introduction, and then I'll have another video that kind of summarizes some of the ideas you would have seen in that investigation, and then in class we'll talk about those summaries.